if I told you that one of the biggest threats to healthy aging is not your heart, not your joints, not even cancer, but the slow loss of the very thing that makes you, you. Your memories, your personality, your ability to think clearly, even your independence. Yet most people don't really understand what's happening inside the aging brain. Today, I want to help to change that. Hi, I'm Dr. William Pierce. I'm a chiropractor. I'm board certified as a non-surgical orthopedist. I'm a sports injury specialist, a peptide researcher, and co-founder of purplepeptides.net. For over 43 years, I've worked with thousands of patients trying to preserve not just lifespan, but quality of life. And one issue I hear more and more from those people like me over 60 is this: hey doc, why am I forgetting things? Why can't I focus? Why does my brain work slower? Today we're going to begin a two-part discussion about neurodegeneration, Alzheimer's disease, and cognitive decline. Not to create fear, but hopefully some understanding, because this is a scary topic. The brain's an incredible organ. It's made up of roughly 86 billion, that's with a B, nerve cells. We call those nerve cells neurons. These neurons communicate through tiny electrical and chemical signals at specialized connection points called synapses. Every memory you have, every emotion, every movement, every conversation depends on those connections functioning correctly. But neurons are not working alone. One of the fascinating discoveries in neuroscience over the past several years is the enormous importance of specialized cells called glial cells. They're support cells in your brain. In fact, the brain contains nearly as many glial cells as neurons. Think of neurons as the stars of the show, and glial cells, well, they're the support crew, or the roadies that keep everything alive and functioning. Two important glial cells are microglia and astrocytes. Microglia act almost like the immune system of the brain. They patrol the nervous system looking for damaged cells, infections, toxins, and even debris. Astrocytes, on the other hand, help support and nourish the neurons. They help regulate communication and maintain an environment which is healthy surrounding the brain tissue. When these systems work correctly, the brain is remarkably resilient. But as we age, as we know, these systems can become kind of dysregulated. One of the most exciting discoveries in modern brain science is something called the glymphatic system. You may have heard of that name. In fact, I mentioned it in a couple videos previously. As you can think of it as the brain's cleaning and waste removal system. When you're deeply in sleep, deep sleep, fluid moves through your brain, almost like a washing machine cycle, clearing away waste products and metabolic debris. This includes substances like amyloid and has become heavily associated with Alzheimer's disease, not being taken care of appropriately. Here's the important point. The glymphatic system works best during deep restorative sleep, meaning poor sleep over years and decades may contribute to impaired brain cleanup and increased accumulation of toxic proteins. That's a huge concept. As the brain ages, several things begin occurring simultaneously. Inflammation tends to increase. Blood flow decreases. Mitochondrial energy slows down. Oxidative stress rises. Repair mechanisms become less efficient. The communication between neurons can become slower and less coordinated. Some degree of mild slowing can occur with normal aging, of course. But neurodegeneration is different. Neurodegeneration means progressive damage and death of the brain cells beyond what we would expect from normal aging. Now, Alzheimer's disease. Alzheimer's is the most common form of dementia. There are several different forms. For many years, scientists focused heavily on one particular protein called beta amyloid. Amyloid proteins can accumulate outside the neurons and form sticky plaques. Think of neurons like homes in a neighborhood communicating with one another with roads and electrical wiring. Now imagine over a period of time that garbage begins to pile up between those homes. Well, the roads become congested, Communication becomes slower, inflammation increases, and the neighborhood becomes harder to maintain. That's one way to visualize beta amyloid plaques. These abnormal protein accumulations may interfere with normal signaling between brain cells, and they may contribute to inflammation and degeneration over time. Again, later, another major player emerged in studies, something called tau protein. Tau normally helps stabilize structures inside the neurons, but in Alzheimer's disease, the tau proteins have become abnormally twisted or turned, forming what we call tangles inside the neurons themselves. So now you have damage outside the cell from amyloid and damage inside the cell from tau. And together, these changes may contribute to progressive cognitive decline. Now, this is important. Modern neuroscience is beginning to realize that Alzheimer's disease is probably not caused by only one thing. It appears to involve many overlapping factors: inflammation, insulin resistance, poor intracellular communication, vascular disease, mitochondrial dysfunction, poor sleep, oxidative stress, genetics, lifestyle, aging itself. In other words, it's likely not one bullet, it's many. Now, genetics. One genetic factor that receives enormous attention is a gene called the APOE gene, specifically a variation called APOE number 4. You inherit APOE genes from your parents. Some people carry one APOE4 allele. Others can carry two. And research is telling us that those with APOE4 appear to have a higher statistical risk of developing Alzheimer's disease later in life. But this is really important to understand. Genes are not your destiny. Many individuals with APOE4 never develop dementia, and many individuals with dementia do not carry the APOE4 allele. What genetics may do is just load the gun. But lifestyle and environment often influence whether the trigger gets pulled. Perhaps the most exciting discovery emerging today is the realization that the brain retains far more adaptability and plasticity than we once believed possible, even as we get older. That matters tremendously because understanding the mechanisms behind cognitive decline also begins showing us possible pathways toward protection and resilience. The reason I wanted to spend this time today explaining this physiology is because understanding this whole process removes the fear. Once you understand the mechanisms, you begin to realize something important. There are potentially modifiable factors involved. Sleep, we just talked about that. Exercise, metabolic health, inflammation, nutrition, stress, even peptides. Those things can all lead to improvement, which is part of our Part 2 discussion. So, in our next video, we're going to discuss what current research suggests may help protect the aging brain. We'll discuss exercise, sleep optimization, blood sugar regulation, supplementation, current biohacks, cognitive stimulation, inflammation reduction, and emerging areas involving peptides and regenerative medicine. Because while aging is inevitable, loss of vitality is not always inevitable. And understanding the brain may become one of the most important health decisions you ever make. Now, in closing, a disclaimer. This video is for informational purposes only and doesn't constitute medical advice. I am a doctor, but I am not your doctor. And no doctor-patient relationship exists between us. So, before you make any decisions about your health, please do so through trusted advisors. I look forward to seeing you on Part 2 coming up soon. Have a great day.